Hello everyone, let's study about the defects of vision. We've seen that for normal human eye, the near point would be at a distance of 25 centimeter from eye, and then the far point goes till infinity. So a human being can see from near point till infinity. That is what is the range of vision. But sometimes, due to some reasons, this range could be modified or altered. That is, a person may not be able to see up to infinity, or a person may not be able to see from a given distance. So the range of vision could vary. That is called as defects of vision. This happens due to many reasons. We look at them one by one. The first type of defect is called as short-sightedness or myopia. So let's define what it means. It basically means that a person affected by myopia will not be able to see distant objects, or it's also called as short-sightedness. So the range of vision will be very short. This is caused due to the enlargement of the eyeball. The eyeball becomes quite enlarged. Here the enlargement is not very significant, it's a very minute enlargement, but still this is sufficient to cause defect, and this defect can be corrected by using a convex lens. You will see this one by one now. So as seen here, for normal human eye, as seen here, for normal vision, an object placed somewhere beyond D, for example, think this is point T. For objects placed beyond D, what is happening here is the light ray from the object is falling on lens and it is falling on the retina. So here it's a normal vision, or you can see it here also as given in this diagram. It's falling on the retina, but due to some reason the myopia enlarges, becomes bigger in size. Then what happens is light from this object falls in front of the retina as given here. That is because you can visualize this to be a case where originally this was the size of the eyeball. So the light ray is actually falling on the old position of the retina, but because of enlargement of the eyeball itself, it appears to fall in front of retina. But do remember that the light is actually falling on the old portion of the retina. Now to correct this, since light is falling in front of the retina, we need to push it away. So that when you divert light is away, for that sake we use a concave lens. So let's try to draw this by a diagrammatic way. So as given here, light from an object, say at the near point, suppose if this is near point, light from the object would fall on retina, would fall on the lens, and the image would be formed in the retina. So there's no problem with this point because the light rays from this would converge on the retina. So this is seen clearly. Now let us assume that this is the point, say point P, up to which the person can see, which means even from here also, if we take light rays, light from here also falls on the retina, falls on the lens, and even this light rays would converge to fall on the retina somewhere like this. So the person can see between the points N to P. Suppose imagine that there's a point somewhere here beyond P, say point R. Now since this point R is beyond point P, keep in mind that the person cannot see beyond the point P. So light rays from this object would fall on the retina, would fall on the lens, but these light rays would fall in front of the retina like this. So these cannot be seen. Now what we need here is we need a lens to push this light ray backwards. So we use a concave lens because a concave lens is a diverging lens. Now keep in mind as to how does it work. The working here is that there is a point P. Now keep in mind that the person can see up to point P. Now this convex lens by its own doesn't form the image on the retina. Rather, this concave lens would form an image at the point P. That is, the image of the object R is formed at the point P because from the point P the eye can see on its own. So many students think that the concave lens or whatever lens we're using, they think that this lens forms an image directly on the retina, which isn't, because this lens forms image at the point P, because of which it can be seen clearly. So for the object kept at point R, the image is formed at the point P from where the eye can see it very clearly. This is what we get. So I can see it clearly. So keep in mind that the image is formed at the point P. So this is how it works. If you want to look at the range of vision, this is the eye. From the person can see from normal point to this point P. So this is the range of vision. Beyond this is cut off. So this myopia can be corrected by using concave lens.